the lesson optics. Optics is the second lesson in physics. Okay, wow. So optics deals with the light energy and then the image formation by light reflection and refraction, lens, mirror, and the uses of lens and mirror. Okay, now we are going to the lesson optics. Light is a form of energy which travels in the form of waves. Yes, light is a form of energy. We travel in the form of waves. Waves means what? Waves mean here light from the source to the next place through the waves that travel. That travel. So they already we know about the sound. Sound also the energy. It has the medium to travel from place to place. But no need medium to travel the light. So light is a form of energy. That is one energy that travel in the form of waves. The path of the light is called the ray of light. Okay, light from the source that go to the next place by the ray. So that is called the path of light. Okay, and group of these rays are called the, you have like the torchlight. Okay, a beam of light coming from the torchlight. So that is the group of rays are called the beam of light as beam of light. Okay, so group of this rays, single ray is the path of light, but the group of rays is called the beam of light. Any object which gives light as termed as the source of light. Okay, sun is the first source of light and energy. Already we know that, but which object emit the light? That is the source of light. That is also called the luminous object. Which one is emit their own light is called the luminous object. Okay, so any object which gives out light are termed as source of light. Some of the sources emit their own light. They are called as luminous object. They are called as luminous object. Okay, like that sun, star, okay, candle. Like that, this is also the luminous object that give the energy, light energy of their own, of their own. They are called the luminous object. Yes. Next, properties of light. What is that? Properties of light. Properties. Well, according to the light and according to the light formation of energy, they are having some properties and important aspects by the reflection and refraction. So reflection and refractions are the main property of the light. What is reflection? No? We know about the reflection. A ray incident on an object that will reflect at that point. At that point, that is called the at that point in the opposite direction. So that is called the reflection. What is refraction? When the incident ray pass through the one medium to the another medium, because the air is one medium, and then through the air to travel into the water medium or glass medium, that will bend. The ray will bend to the second medium. So that is refraction. First medium to the second medium. In the first medium, the path of the ray is straight, and then in the second medium, the path of the ray will be bent. So that property is called the refraction. Understand? So the property of light and the important aspects on refraction of light is, for light, first one is light is the form of energy. Light is a form of energy. Okay, light is one type of energy that formed by the energy only. Energy only. Next, light always travel along a straight line. Yes, that is it. When the light source is present, the light path of the light rays is in the opposite direction only, or not in the opposite direction. That is in the direction, that is go in the single direction only. Okay, not in the various ways. So they are called the light always travel along a straight line. And then light does not need any medium, for its propagation. Light does not need any medium for its propagation. What is propagation? Propagation means that go in straight line. Light travels in the straight line. So that is called the propagation of light. That is called the propagation of light. So light does not need any medium for its propagation. Okay, then already I told that light has no medium to travel. Okay, it can even travel through vacuum. Through vacuum, it can even travel through the vacuum. Vacuum means what? No air in that case. So no air. There is a medium. Air is a medium. Without air, the light can pass through that. Yes, the speed of the fourth one. The speed of light in vacuum or air. Speed of light. Speed means place that travel from one place to another place. What is the speed? C is equal to 3 into 10 power 8 meter second minus 1. That is derived by the scientist. This is the constant value. So C is equal to 3 into 10 power 8 meter second minus 1. Next, since light is in the form of waves, it is characterized by a wavelength. Okay, since like, this is one of the important property. This is derived by that. What is the related between the form of waves? Light is a form of waves. How is it formed? What is the character for this wavelength? By the waves only. So wavelength unit is that represent the lambda. That is represented by lambda wavelength, and the frequency v. Frequency v. So which is related by the following equation. C is equal to v lambda. C is equal to v lambda. C the velocity of light. C is the velocity of light. Okay. Next, different colored light has different wavelength and frequency. Okay, so different colored light. What are the different colored light? Different colored light. We are using so many colored bulbs. Okay, so different light has a different color wavelength. The wavelength will be different for different color light, and frequency also. And frequency also. Among that, visible light, violet has the lowest wavelength, and the red light has the highest wavelength. So VIBGR, already we know the spectrum. Spectrum, we get the 7 colors from the white light. And among them, so many colors also present. Violet is the lowest wavelength, and the red is the highest wavelength. Okay. Next, eighth one. When light is incident interface between two media, it is partly reflected and partly refracted. Okay. Incident, when the light is incident on the interface between two media means one media air, another one media water or glass, any two medias. We can take any two medias from the one media to another media. When the light rays passed, that some of them reflected means that come back in the opposite direction. That is reflection. Partly refracted means what? That will be bent. That will be bent to the next media. Yes. Next then, refraction of light. What is refraction? When the light, now look at reflection. What is the refraction definition? This is when a ray of light travels from one transparent medium into another obliquely, the path of the light undergoes deviation. This deviation of ray of light is called the refraction. Yes, when a ray of light travels from one transparent medium into the another, we can take any medias, air, water, glass prism, silver, ever silver, like that. No. any medium, we can take any medium. One is denser, one is lesser, lesser medium. One is denser, another one is lesser medium. So from the lesser to the denser or denser to the lesser, we can take any two medias. Okay, wow. So one transparent medium into the another. The path of the light undergoes deviation. Undergoes deviation. Deviation means that will bend. That will bend. Okay, not in the straight way. That is deviation. Okay, so this deviation of the ray of light is called the refraction. This is one of the important definition. Okay, next, refraction takes place. Where all the refractions takes place? Due to the difference in the velocity of light in different media. Okay, refraction means in different media only that will happen. So velocity of light will be changed. Yes, according to the velocity, the refraction will be differ. Already now only we know that violet is the violet has the less velocity, length, less length, and then the red has the highest length, wavelength, highest wavelength. So the velocity also different. According to the velocity, the refraction will be happen. Okay, next is the velocity of light is more in the rarer medium. Velocity means what? Already the velocity means that is speed in direction. Speed in direction. So that is velocity. Okay, so velocity of light is more. Another one thing, velocity depend upon the time also. Depend upon the time also. According to that, the velocity of the light is more in the rarer medium. Is more in the rarer medium and then less in the denser medium. Less in the denser medium. Which is rarer medium? Rarer medium means air. Denser medium means glass prism. Glass prism is thicker than the air. So that is called the rarer medium and denser medium. Okay, wow. So refraction of light obeys two laws of refraction. Okay, according to this, so these are the postulates of the refraction of the light. Okay, wow. Now refraction of the light obeys two laws of refraction. Two laws of refraction. The first law of refraction, the velocity of light is more in a rarer medium and less in a denser medium. Understand? This is the first law. This is the first law. The velocity of light is more in the rarer medium, less in the denser medium. Understand? Next, second law. What is that? The ratio of the sine of the angle of incidence and the sine of the angle of refraction is equal to the ratio of the refractive indices of the two media. Okay, ma'am. So already we learned from the sixth standard onwards, angle of incidence, what is angle of refraction. Okay, ma'am. A path of light, a path of light, a path of light or a ray pass through the medium. Okay, ma'am. That will go and fall in one place. That ray is called the incident ray. That will reflected or refracted through the another medium or glass prism, come out from that medium. That is the emitted light, emitted ray. Okay, incident ray, next refractor ray, and then emitted ray. Okay, already we know that. So like that, in this experiment only, we calculated the angle of incidence. When the incident ray falls on that media, we measure the angle of incidence. When the ray, that ray will be refracted through the prism that will come out. At that place, we measure the angle of refraction. Okay, but that will happen the same angle. So the ratio of the angle of incidence and the angle of refraction is equal. Is equal, and the ratio of the refractive indices of the two media. What is refractive indices? Sin I by sin R is equal to mu2 by mu1. Mu2 by mu1 is the formula to find out the refractive indices. Find out the refractive indices. This law is also known as Snell's law. This law is also known as Snell's law. Okay, wow. So the ratio of the sine of the angle of incidence and the sine of the angle of refraction is equal to the ratio of the refractive indices of the two media. Okay, that's the sin I by sin r, mu2 by mu1. The refractive index gives us idea. The refractive index only give them how fast, how slow the light travel in the medium. Okay, and then the ratio of the speed of light in vacuum of the speed is the speed of light in a medium is defined as the refractive index mu of that medium. Mu of that medium. Okay, so we derived from the refractive indices, refractive index, and then also in which medium the velocity of the light is higher or lower. Like that, we will derive from this Snell's law only. That is the second law of the refraction. Okay, yes. The speed of light in a medium is low. Okay, in a medium. Next point, the speed of the light in a medium is low if the refractive index of the medium is high. Okay, medium is low in the air, in the water. The speed of the light is high. But in the, but in the, yes, Ji, yes, Ji, okay, Ji, okay, Ji. Okay, the speed of the light in a medium is low. In the high means the medium is less. The medium is low. When the speed of the light is medium is low, if the refractive index of the medium is high. Okay, when the light travels from the denser medium into the rarer medium, the refractive ray is bent away from the normal drawn into the interface. What is normal now? When the incident ray falls on medium, that point only that will reflected or reflected. So the incident ray and the refracted ray lie in a same plane. That plane is called the normal. That plane is called the normal, drawn into the interface. Yes. Next, when light travels from the rarer medium into a denser medium, the refracted ray bend towards the normal, drawn to the interface. Next, refraction of a composite light and the dispersion of light. Composite light means what? Composite means what? The white light dispersed into the 7 colors. So that is called the composite light. Okay, now we know that sun is the fundamental and natural sources of light. We know that sun is the fundamental and natural sources of light. We understand this. Sun only the natural sources that only give the light energy and heat energy. Okay, yes. So sun is the first source of the light. So that is called the fundamental and natural. Okay. If the source of light produces light of a single color is known as the monochromatic source that were produced only single color. Suppose they produce different color is called the composite source of light. Okay, produces a white light and then light is different colors. Sunlight is the composite light which consists of the light of various colors or wavelength. Various colors or wavelength. Already we know that the sun ray dispersed into the 7 color that is called the spectrum. Okay, so with ZR, it's from the going violet to red. Okay, lower wavelength to the higher wavelength. Okay, so this is called the composite light. Yes, various. And then another one example for the composite source is mercury vapor lamp. Mercury vapor lamp. Mercury vapor lamp also give the so many like various colors of the rays. Various colors. Okay, so when a beam of white light, when light travels from a rarer medium into the denser medium, the refracted ray is bent towards the normal, drawn to the interface. Drawn to the interface. interface. Okay, the refracted ray is bent towards the normal drawn to the interface. Yes. Next in, when a beam of white light or composite light is refracted through any transparent medium, such as glass and water, it is splitted into the component colors. Yeah. So this is refracted through any transparent medium, glass prism and water, that is split up into the composite color, that is the dispersion. This phenomenon is called as dispersion of light. So through this dispersion only, the band of colors, the spectrum will be created. Okay, the band of colors is termed as spectrum. This spectrum consists of the following colors. What are they? Violet, indigo, blue, green, yellow, orange, and red. Okay, these colors are represented by the acronym WIBCR. What is the acronym? WIBCR. Okay, yes. Why do we? Next in, different color. We get the refracted transparent medium. Why do we get the spectrum? How we get the spectrum? White light is refracted by the transparent medium. This is because different colored lights are bent through different angles. Yeah, this is also one important reason for this. Different colored light bent through the different angles. Okay, where already we know that what are the angle of incidence, angle of refraction. So different wavelength having. Okay, so different colored lights have different angles. So they bend through that different angles. Okay, because they are having different wavelengths. Then only they bend through in different angles. This is one of the important property. Yes. That the angle of diffraction is different for different colors. What is the angle of refraction? Is the smallest for red and the highest for violet. Angle of refraction, when they refracted, they come out from the medium. That is angle of refraction. The angle of refraction is smallest for the red. Red is the first color. Okay, the highest for the violet. According to the Snell's law, we know that angle of refraction is determined by the refractive index of the medium, and then the refractive index of the medium is different for different colored lights. Okay, this indicates the refractive index of the medium and dependent on the wavelength of the light. Next is scattering of light. What is scattering? Scattering means what? When the light enters the earth atmosphere. Yeah, sun is far away from us. But the sunlight falls on the earth. That is not directly false. That will refracted by the atoms and molecules and different gases, dust particles are present in the atmosphere. Okay, how they entered on the earth? Thus, when sunlight enters the earth atmosphere, the atoms and molecules of different gases present in the atmosphere, okay, refracted the light in all possible directions. That is called the scattering of light. First one is a ray. A ray dispersed into the 7 colors. That is dispersion. Here, when light rays, the sun rays will fall on the earth by them scatterers. What are the scatterers? Atoms, molecules, different gases, and dust particles also. Dust particles, okay, moisture, these are also the scatterers. Okay, according to this, they are in the atmosphere, they refracted the light in possible directions. In all possible directions. Okay, so this is called the scattering of light. Okay, in this phenomenon, in the scattering of light, the beam of light is redirected in all directions. Okay, not in the one direction. So the sun rays redirection in all directions when it interacts with the particle of the medium. What is the particle of the medium? Now, what are the particles? Atoms, molecules, dust particles, and moisture. These are all fully particle of the medium. Okay, wow. So the interacting particle, the interacting medium is called as scatterer. Yes, yes, the okay, okay, the scatterer. Yes, okay, ma'am. Now types of types of scattering. Types of scattering. When the beam of light interacts with the constituent particle. What a constituent particle means? Scatterer medium. It undergoes many kinds of scattering. Okay, wow. Okay, wow. Based on this initial and final energy of the light beam, scattering can be classified into elastic scattering and inelastic scattering. Okay, ma. This